You know, water has greater amount of specific heat, greater value of specific heat. That's why it is also known as natural cooler, natural refrigerator for poor persons who can't afford AC and refrigerators. At the same time, the entire existence of aquatic life is also based on this phenomenon that water has the greater specific heat. Because of its greater specific heat, normally it lags behind in getting cold or in getting heated. In summer season, you see that water always lags behind in getting hot. That's why at noon, if you compare earth and water, both, you will find that water is comparatively colder than earth. For the simple reason, it is lagging behind in getting hot. Similarly, here also, when the temperature, because of snowfall and all that, when the temperature of atmosphere goes below 0 degrees Celsius, water lags behind and still it hasn't gone below 0, and that's why a temperature difference is developed between the water and air above it. Now, what happens? This is comparatively hot, then the air and heat transfer takes place from water to air. The heat regularly gets transferred to the air and the freezing will start, because ultimately above it finds the temperature has gone below 0, and for water the freezing point is 0. Because of the regular flow of heat from water, ultimately it will start freezing. So, we notice one thing, that freezing of water has started from the top of the lake, it's never from the bottom. Freezing starts from here, and now whatever the ice would be formed, that will be below at the bottom layer. This will continue. You might ask me, it is a solid and it is not getting sink, it is floating still on water surface, for the simple reason that ice has density less than that of the water. You know, it's a very common fact that ice always floats on water. So, sometimes it happens that people normally see one layer is there on the lake and they just imagine that it is a piece of ice, and they try to check it, and they go inside because it was a very thin layer of ice. You see, so it's a point to remember that the freezing of lake always starts at the top layer. Now, suppose this layer has become of thickness x, this is ice layer, and this has got the thickness x. Above it is low temperature. Here water is not that low as it is the air. In between there is ice at 0 degree. This you will consider 0 degree, and this is minus theta, this is x. Now, the heat that is going to flow will be given by Ka. What is A? A is the surface area of this lake that we have considered, for example, in derivation. Q is Ka delta theta is 0 minus theta, that is going to be theta only, Ka theta. Suppose you are considering the time dt, and this is x. The heat that has flown in time dt will be given by this relation. Then dq dt, this is the rate of heat transfer. Heat transfer will be given by, q equal to m s delta theta or m c delta theta. So, or it could be written as m into L. This could also be written as m L K A theta dt upon x. See, we have reached the stage where the freezing of lake is continuing, and freezing is always taking place at the bottom of ice floating. When ice has frozen, ice has developed on the top surface of lake, you see at that time also the water at bottom is at 4 degrees Celsius. This is simply because the water at 4 degrees Celsius has the maximum density, and you also know that why ice floats on water surface. You see, whatever be the temperature, there are no historical evidences so far when we could say that entire lake has frozen, because the thickness of ice layer as it goes on increasing, the rate of formation of freezing of ice or freezing of lake goes on becoming slow and slow, and there is no example, no evidence when the entire lake was frozen. That means the lake at the bottom is always at 4 degrees Celsius, and all the aquatic life, all the sea animals, sea fishes are quite safe at the bottom, though the ice has developed on the top, and because of the oxygen inside, that life is still assured. The rate of formation goes on decreasing with the increase in thickness, and time taken in the change of ice thickness from x1 to x2 will be given by T L d upon 2 k theta x2 square minus x1 square. What we have considered here is that T is the time taken in change of thickness of ice layer from x1 to x2. Now, if you want to see the ratio of time in change of thickness from 1 to 2, and then from 2 to 3, then from 3 to 4, it is going to be simply in the ratio 1, 3, 5. But if you want to find the total time in the formation of thickness of ice layer by 1 centimeter, you just put here x1 equal to 0. In that case, you are going to get the relation L d upon 2 k theta x square. That means you want to find the time taken in the preparation of ice layer by 1 centimeter. Here you will put 1 square. You are interested in finding the time in formation of ice layer by 2 centimeter, you will put here 2 square. So, obviously, this ratio is going to be in the ratio 1:4:9 that we have given over here. This is the complete time in the formation of ice layer by 1 centimeter, by 2, by 3. Whereas, if you are interested in finding the time interval from 1 to 2, from 2 to 3, from 3 to 4, this one, that is going to be in the ratio 1:3:5.